Hi, welcome. This is a video of just one example of logarithmic differentiation. Logarithmic differentiation is an advanced technique, so I don't usually give more than one problem in it. I've given you one as a discussion board in my class for Calculus 2. And the one on the discussion board is very similar to this one. It's just instead of having x as the variable, it has t as the variable, and it has one more factor on the bottom. But logarithmic differentiation is useful for finding the derivative of functions that are otherwise difficult or impossible to take the derivative of. So we're going to be using logarithmic differentiation for this one. There aren't any of those on your homework because it's an advanced topic, but you are going to do one of them on the discussion board that's similar to this one. Okay, so we want to find the derivative of y equals 1 over x plus 1 times x plus 2 times x plus 3 times x plus 4. So the idea is when you're doing logarithmic differentiation is instead of taking the derivative directly, first you apply a natural logarithm to both sides. Okay, so apply ln natural logarithm to both sides. And the reason it's called logarithmic differentiation is you actually do that logarithm of both sides as your first step. And it's just an advanced technique that you can use on problems that are difficult to do the derivative of. Like this one, it's difficult to take the derivative of because you could use the quotient rule and then repeatedly use the product rule, or you could distribute on the bottom and then use the quotient rule. But either way, it would be very difficult to simplify all the fractions. So we're going to be doing logarithmic differentiation for this one. So we're going to apply ln to both sides as our first step. So we get ln of y equals ln of the right side, which is 1 over x plus 1 times x plus 2 times x plus 3 times x plus 4. Okay. And that's always your first step with logarithmic differentiation, is you apply a natural logarithm to both sides. You could also apply another logarithm, but people usually use natural logarithms. Okay, so now that we've done that, our next step is to simplify the right side using properties of logs. So in particular, with this one, we want to use the property of logarithms called the reciprocal property. Okay, so reciprocal property of logarithms. So reciprocal property of logs. All that says is that ln of 1 over u is equal to negative ln of u, where u is any expression. Okay, so here, this ln of 1 over all of that is just the same as negative ln of the entire denominator. Okay, so if we do that, we're going to get ln of y equals negative ln of x plus 1 times x plus 2 times x plus 3 times x plus 4. So that's just the entire denominator. And these properties that we're using are properties of logs from pre-calculus. So some of you may remember them, other ones might need to refresh them a little bit. But again, we just have this one problem that we're doing just to kind of get our feet wet on the idea of logarithmic differentiation. Okay, so we use that reciprocal property of logs, and then the next property that we use is called the product rule for logs. Okay, so the product rule we can use to simplify the right side. We're actually going to be expanding the right side, so I shouldn't say simplify. We're expanding the right side. Okay, so expand the right-hand side of the equation using, it's called the product rule for logs. It's from pre-calculus. Product rule for logs. And the product rule for logs just says that basically if you're multiplying inside the logarithm, that's the same as adding outside the logarithm. Okay, so multiplying inside the logarithm, multiplying inside of the logarithm is the same as adding outside the logarithm. It's the same as adding outside of your logarithm. So again, that's something that should ring a bell from pre-calculus. So like here, because we have a minus out front, we're just going to keep the minus out front. But we're going to expand all these things multiplied together and write them as a sum of logarithms. Okay, so we're going to have ln of y equals negative ln, well, I'm going to put brackets around this whole thing. So we're going to have ln of x plus 1 plus ln of x plus 2 plus ln of x plus 3 plus ln of x plus 4. Okay, so what we're doing here is we took all these things multiplied together inside the logarithm, and then we used the product rule for logs to expand it. So we added all the logarithms on the outside, which is the same as multiplying the x plus 1 times x plus 2 times x plus 3 times x plus 4 on the inside. Okay? So we expanded that, and don't forget we still have a minus out front, so I put brackets around the whole thing. And obviously we're going to have to distribute that minus before we can take our derivative. So that's what we're going to do next. We're going to distribute the minus to every single term on the right side. So if we distribute that minus, we're going to get ln of y equals negative ln of x plus 1 minus ln of x plus 2 minus ln of x plus 3 minus ln of x plus 4. So all we did in that step is we distributed the minus. Okay. All right. Now I know this is a lot of steps, but the one on the discussion board is very similar to this one, so you can follow this. It's just the same idea, only the variable is t, and it has one more factor. Okay? So what we can do now is, once you've simplified the right side like this, now you can actually take the derivative of both sides. Okay, so take the derivative of both sides. Take the derivative of both sides of the equation. And remember the rule for the derivative of a natural log is d dx of ln of u equals 1 over u times u prime. Okay, so the derivative of a natural logarithm is 1 over the inside times the derivative of the inside. So 1 over u times u prime. Okay. So yeah, we're going to take the derivative of every single term on the right side and also the derivative of the left side. So on the left side, the derivative of ln of y is going to be 1 over y. But then we have to use the chain rule. So it's 1 over y times the derivative of y. So it's 1 over y times y prime. So that's the derivative on the left side. And then on the right side, we're going to be taking the derivative of every single term, one by one. And that's why logarithmic differentiation makes this problem a lot easier, because now on the right side, these should all be easy to take the derivative of. Remember, the minus just stays out front because it's a constant. And then the derivative of ln of x plus 1 is just going to be 1 over x plus 1. So we're going to have negative 1 over x plus 1. And then if you use the chain rule, that's just going to be times the derivative of x plus 1, which is just 1. So you don't really need to write times 1 here, because the derivative of x plus 1 is just 1. Okay, so we're just going to write negative 1 over x plus 1 minus 1 over x plus 2. Same thing. The derivative of ln is 1 over, and then the derivative of x plus 2 is just going to be 1, so we don't need to write it. Okay, and then we're going to have minus 1 over x plus 3 minus 1 over x plus 4. Okay, so on the right side there's a total of 4 terms. And then on your discussion board there's actually should be a total of 5 terms, because there's one more factor in the original problem. Okay? And yes, it's a hard problem, but hopefully this video will help make it a little bit easier, because it's quite similar to this one. Okay, and then that's considered done on the right side, but we need to actually isolate this y prime. Remember that y prime is the same as dy dx, or on the discussion board it will be dy dt. Okay, so instead of writing y prime, I'm going to go ahead and write dy dx. And what we have to do now is isolate the derivative. So we need to isolate dy dx. Okay, so that's the next step here. So for that one, to isolate dy dx, we just need to get rid of the 1 over y by multiplying both sides by y. Okay? So we'll go ahead and multiply both sides of this equation by y, and that's going to give us dy dx on the left side, and then on the right side I'll put parentheses around the right side. So we're going to have y times this huge number of fractions here. So y times a parentheses negative 1 over x plus 1 minus 1 over x plus 2 minus 1 over x plus 3 minus 1 over x plus 4. Okay? And just like magic, we're almost done with the problem. So the last step of the problem is to replace y with the original expression that they gave us at the beginning. This is the kind of the cool part, the magical part. Okay, so your last step is replace y with the original expression. Replace y with the original expression in terms of x. Now, in the original expression on your discussion board, it'll actually be in terms of t, but you're still going to plug in the original expression in terms of t. So here we're going to plug in the original expression in terms of x. So if I go way back up here to the beginning of the problem, we said y equals 1 over x plus 1 times x plus 2 times x plus 3 times x plus 4. So we're actually going to replace the y at the very end with this whole thing. Okay? And that's kind of the magical step at the very end, and then you're done with the whole problem. Okay, so let me zoom out, because this is going to have it's going to take a lot of room. Okay, so at the very end here, we're plugging in the original expression in terms of y on the right side. Okay, so the original expression was 1 over x plus 1 times x plus 2 times x plus 3 times x plus 4. Okay, we're plugging that in for y. That's this y right here. I replaced it with the original expression. And then we still have all of this. So this is times negative 1 over x plus 1 minus 1 over x plus 2 minus 1 over x plus 3 minus 1 over x plus 4. Okay, and that right there is the answer that we're looking for. So since the discussion board problem is very similar to this, it's just in terms of t and it has one more factor, hopefully you'll be good to attempt the discussion board problem. And remember, you get credit for trying the discussion board problem as long as it looks like you attempted it. You don't have to get it correct. It just has to look like you attempted it. It's sort of like attendance. Okay, so I hope this video helps, and thanks for watching.